In the two previous lectures, we have been creating a simple web application with a front end in Fable and Elmish and Felice, and a backend in ASP.NET Core and Giraffe. And in this lecture, we're going to complete the app and add a database backend to it, and coupled with that a REST interface. And once you have these skills under your belt, you pretty much know, I would say 80 to 90% of the stuff that you need to create any type of typical business application in F#. So first we're going to talk a little bit about databases, how to deal with databases in F#, various types of databases, and then see how that connects to sort of REST interfaces, and with particular focus on the create, read, update, and delete operations, and see how to implement these things. Databases. I have a little bit of a complicated relationship to databases. On one hand, they're super useful and powerful and lovely in every way and fantastic, but on the other hand, I always find them to be very complicated and hard, and there's a lot of specialized knowledge for each database, and it's kind of difficult. So in this presentation, we're just going to scratch the surface a tiny little bit and see just the sort of super basics of it. My view is basically a database is a glorified file system with a lot of complexity on top of it. But of course, we need that complexity, so we shouldn't be complaining. Anyway, broadly speaking, we can divide databases into two classes: SQL databases and NoSQL databases. It's not really a proper classification because it doesn't say really much about what sort of background technology there is. There are plenty of strange databases with SQL interfaces to them. But in sort of, when I say SQL database, I mean relational database. And the NoSQL databases are, well, non-relational. From a programming perspective, usually what we will find is that typically SQL databases will come with some sort of SDK to interface with it. They will be listening on some special port, which is highly dependent on the database implementation. If it's Postgres, if it's a Microsoft SQL server, or if it's Oracle, or if it's MySQL, and so on. It all depends. And typically you have some libraries that you link into your code and you to access those databases, and they will take care of talking the right protocol with the right server. Whereas very often we find that these modern, or I shouldn't say modern, but these NoSQL databases, they come very often with REST APIs, which are simple. You can use them from the command line using just curl, or you can just use the same techniques as we used in the previous lecture to do just web requests from the client using, or from the server using .fetch. So in the broad sense, we have relational databases, which is your typical SQL database like Postgres or MySQL or Oracle. Then we have like table databases, we have graph databases, which I actually think I really like graph databases for certain things. They're great. And if you haven't looked at graph databases, please do, because it's great fun, and they make you look at the world in a different way. We have document stores, we have key value stores, we have in-memory databases, and so on and so on. Plenty of different things. So if you want to get a good quick overview of databases, there's a book called Seven Databases in 7 Weeks, which is quite sort of give you good introduction to a lot of different types of databases. So we're going to be talking about traditional relational SQL databases and see how we can access them from F#. And in principle, we have three major ways of doing this. One is that we can just use the SDKs directly and access the database using raw SQL strings. So we will simply write in some SQL queries directly in SQL and send them off to the server to execute, and we'll get data back. That's one way of doing it. I don't particularly recommend it, so there are more convenient ways to do things. Another is type providers. I talked a tiny little bit about type providers in a previous lecture, and there is a SQL provider, and it's pretty, in principle, pretty nice. But our experience at work is it might be good for data exploration and for toying with and so on, but for production work, not really good. Things like compile time start suffering because it always, whenever you want to compile your code, it doesn't really know whether the database has changed, so it has to contact the database and it has to generate all these types and it has to so you get recompilation over and over and over again, amongst other things, and they hide a lot of complexity, and at some point it's going to haunt you and come back and bite you. So we sort of gave up on type providers. You can try them. It's good to know about. And the third way to do things is using Entity Framework, and in particular Entity Framework Core, which integrates with the .NET Core. And Entity Framework Core is a so-called object relational mapper, where you get a object-oriented object interface on top of your database layer. Now, you might think that, ooh, that sounds not so nice, and well, depends, but it's actually quite nice. And the Entity Framework Core is a very lightweight system compared to other ORMs out there. So we have nice and good experience with Entity Framework Core. One of the things that you do get with Entity Framework Core that you don't get with raw SQL, and what you don't get with type providers, is that as you evolve your code and you update tables, you add data, remove tables, you remove, add columns, and so on, you actually get migrations, proper ways of making sure that your database consistency and your databases are updated properly. And this is a very important property really in production. And if you have worked with Rails or Django or many of these things, they all come with some form of ORM and migration system to make sure that the database stay consistent. Entity Framework also has this nice property that it will work offline. So you don't have to have your database online. This is a problem that you have with type providers. It needs to contact your database in order to generate these types. And that kind of sucks when you're on a plane somewhere high up in the sky and you can't connect to the server and you can't compile your code. Although you haven't changed anything that has to do with the actual database. One of the sort of drawbacks with Entity Framework Core is that it's C#. Well, you can do it in F#, and I've done it, but I find that it's not really worth the effort. So what we typically do is that we just have this tiny little C# project where we define these classes for our database tables and close our eyes and think about something else. While I'm saying this, please, if you're going to do anything serious with Entity Framework Core, go and read the documentation and read it carefully and skim through so that you have a good overview of it. There are loads of pitfalls with this thing, and you can easily make stuff that either executes client side instead of server side, and you get huge data transfers over the wire and things go miserably slow. You can even get corrupted data if you're not careful and do things in the wrong way. So please go and read the documentation. It has very good documentation, but there's a fair amount of stuff to know about it. For really simple things like we're gonna do today, we can just do it. But if you're gonna do anything serious and where people's lives depend on the data integrity, make sure you have read the manual. So, .NET Entity Framework Core comes with a command line tool that you can use it from the .NET command. So you just install it using this .NET tool install -g .NET-EF, and in principle it has three main subcommands. One is migration to sort of to convert your changes to the database model into these migrations that will then be run on top of the database. Then it has this database command where you can update databases and the actual database, not just the sort of specification. And you have to tell it which database, of course, to connect to and run updates and run the migrations. And then there's actually a one called db context, and under there you find a nice command which can help you get started, which is scaffold. And if you use this db context scaffold, you can give it a connection string to some database. It can be a SQLite, or it could be a Microsoft SQL Server or Postgres, and you just point it to that database and it will generate all these database tables for you, or these objects for you, and then you can just go in and tweak and edit and create a new migration and update the database. So that's a very useful thing if you already have a database. But we're going to look now how to sort of set this entity framework up from scratch. So since this is going to be, for us being F# programmers, this is going to be a C# program, we're going to have to set up a separate project. So one of the first things that you have to do is that you have to go and say .NET new class lib and set up a class library. And it's going to be a C# project. And in that project, you create you create your model. I typically call it model.cs, and here I've created a sort of slightly compacted version of what we will do later in the demo. So put it in a namespace. I've called it entity. You can call it whatever. Then you create a class which is going to be your database context class, where all your tables are going to reside. I've just called it data context. You can call it foobar if you like, but it has to inherit from this db context class. And then we list these properties which are of the type db set of some type. And a db set is in principle just a database table. So that sort of represents the table. So here I have only one table. It contains data of type person, and the table is called people. And here below I've defined this class person, which defines the data fields, the columns in this person. And the first one is an integer. It's called person ID, and I've annotated it with an annotation called key. Now, if you go and look in the documentation, you will find that there are a lot of these various types of annotations that you can put on data. You can say, well, whether they're required or optional. For strings, you can say the string length, primary keys, secondary keys, what the name of the actual field should be inside the database compared to in the objects that you're using, and so on and so on and so on. There's plenty of these things. Now, in fact, this key annotation here is not really strictly necessary, because when Entity Framework looks at this stuff and it sees that it's an int and it ends in ID, it automatically treats it as a key. So you don't really have to put the key on it. Here's another full name column, which is a string. And finally, we have a optional int, which is the age. So putting a little question mark behind it. This is modern C#, so you have to tweak the project file a little bit. I'll show you in the demo in order to get access to this. Otherwise, you're going to have to say, put some annotations on top of things. But this is quite a nice way of doing it. So this sort of creates now our database definition. It has one table called people, full of persons, and the columns of the person table is defined like this. The next thing we have to do after we have created this is that we have to create a migration, which is a recipe for how to translate this this object definition into a database table definition. And that we do by running .NET EF migration add to create a new migration. And this is going to be our first. I've just called it initial. You can give it just whatever name you like. And then I say -s, and I have to give it the sort of startup project. And this we have to do because we have put this entity project in a separate class library project. So we need to say, okay, what's the startup project, because it needs to do compilation and see that everything matches up. And then I say that which context it should use, because you can have multiple contexts database context in one project. So I say, okay, you should use the data context. And if all goes well, then you just run .NET EF database update, and I give it the server project again, and it will run the updates and set up the database for us. So in this case, we wouldn't even have a database. It would just scaffold it up completely from scratch. In this example, we're going to be using SQLite because I don't want to bother with servers and setting up permissions and the containers and what have you. So we're just going to have a database in a file. So this will actually, running this database update will create the database file in the server directory and set up the tables in there. Now we have a database. So now we can go back to F# and use the database. And to do that, we're going to be using a computation expression I haven't really talked about. I think maybe I mentioned it, which is the query computation expression, which is a layer around the underlying link system of .NET and .NET Core. Now, link is a built-in language. It's language integrated query. It's a built-in sort of query system for in the Microsoft.NET platform. Comes with a standard library and allows you to query a load of different things. So let's see how this works. The first thing that we need to do is that we need to get hold of a context, and you say that I have, say, let context and then entity. That was the namespace that I created, and then I had this data context class inside of it. So we're just gonna instantiate the data context class. And then I can say query for I in, and then I use the context dot people, which was the name of the one and only table we have, do, and then I will select all entries where full name contains the string Bob. And that will return me a query object, which implements the IEnumerable interface, which means that it's in F# parlance, it's a sequence, and I can say, okay, make an array of this sequence, and now I have a normal F# array with all the people who has the name Bob in their name. So it's pretty straightforward. In the demo, we will look at how to add and update and create and delete entries from tables using this query computation expression. So I said that basically any object which implements the IEnumerable or is a sequence and any sequence can be queried. So we can actually do things like this, which might sometimes be useful. So here I created just a simple list of numbers, 1, 2, 3, and I can say, well, instead of using, for example, filter or something else, I could say query for I in example here, or this ex do select everything where I is greater than 1, and then turn it into an array. So you can actually use these queries in places. This can be quite a nice way of doing things. If you end up with complicated map filter combinations to manipulate data, this can be much more readable. So keep that in mind. The only little thing I have to say about REST, I presume all of you know about REST and CRUD. But we're going to do a proper REST interface for these database operations, and then we're going to use write an API which uses the get, update, and put, patch, and delete verbs. So you're going to see an example of that. All right. So the demo I have is the same app that we've been working on. This silly people table with the graphs and stuff, and you can find it on GitHub, on my GitHub page. What we're going to do now is that we're going to add the entity framework. We're going to add the API endpoints, and we're going to implement them, and then we're going to have to update the client. I will not talk about updating the client today, and I also try to keep this very short. So I will just skim through things, and you can try these things for yourselves with a demo to see how it works. So just try to keep it sort of terse. All right, so let's look at the code. So the one thing that I have added to the project since the last lecture is a new folder. I've called it entity. So now we have a client and the server and the shared, and now we have this entity folder. And entity just contains, I just added an entity CS project, and there's a model.cs. Now, in order to use C#8 with .NET Core, you have to go in and set two things. In the first top level property group, you have to add this nullable enable thing, and then you have to upgrade the net standard to 2.1, and then you're set. Then you can use these question marks in your model. So let's have a look at the model. Here are some using system, collections generic. You need the entity framework core, and then to use these data annotations like key and so on, you need to include these namespaces as well. Create the namespace, entity, create a new class, which is our data context. We add this DB set, this table of persons called people, and then here's a method I didn't show you, which is on configuring, and you can see that, read the documentation about this. But here basically I say use SQLite and say that okay, the database is supposed to be called data.db, and that's it. And then I create the person class to represent the columns, and here's the person ID. I have a first name, I have a last name, I have an optional alias, and I say that the maximum length of the alias can be 32 characters. We have an integer age, and we have a integer height. And then I create a default constructor for this class, how to create empty persons, and so that it doesn't complain. And now, in principle, I could just go to the terminal here, and I could say .NET EF migrations add. Now I already did this, so I can run this, and I run it with the verbose flag pause, so you can see what's going on, and it will start running and creating things. Now it can't, since now the server is running, this will fail because it can't change the files and so on. So, but and I haven't changed anything, so it should just say, oh, stop. But that was basically it. and then I could say .NET database .NET EF database update -s dot server, and I could update the database. See what happens there. Well, something's going on, but okay. Build fail for probably because the database is also in use and locked. So, all right. So let's go back to this thing. So after having run this initial migrations, I can go in and it creates this migrations folder, and here are some generated C# files for those things. And if you're interested, you can go in and see what they contain. There are also commands, if you read the documentation, there are also commands and ways to sort of see the SQL commands that get generated from the entity framework. So you can go in, if you have a performance problem, you can go in and try to sort of debug and figure out what's going on. So that was the whole entity thing. That was defining the database. The next thing we need to do is, of course, add code in our F# world to use this database, and that I've created in the server project. Now I can go back to the F# view of things. I've created a new module. I call it DB, and we can open it up and have a look. And here I include the Entity Framework Core to get access to the Entity Framework Core stuff, and that's basically all I have to do. One of the things that I usually do is that, because what we're going to do is that we're going to open up these database context, use them, and close them. So I create a little helper to do that. The reason why we have to open and close many times is that if you don't, things get cached. And you might also run out of database connections and all kinds of things. So don't try to sort of sit on and hold on to these database connections for too long. That's just for general sanity. So here I've created a function which I call runDB, which takes a query, and that query is a function which will be given a data context, and then it will run some sort of query and have wrappers around it. Otherwise I have to write this over and over and over again, so this makes just my life a lot easier. You'll see. One of the nice things that you get with Entity Framework Core is the possibility to run these database migrations when your application starts. So suppose I have a number of running instances for 5 or 10 or 100 clients of a software. I make a new version, I update the database, I do the migrations, and now I have this dilemma. How should I do this? Should I connect to all the individual databases and script that somehow and upgrade the database while the application is running? And then the application that is running will either corrupt the database or get in trouble and crash before I have time to update the application. Or should I update the application, which will then crash because it can't use the database because it's in the wrong format? So, with Entity Framework Core, you actually get this, on the context, you get this database migrate thing, which will run the migration for you. And you can just add this, I created this try migrate function. I put it in the startup. So all I have to do is as I restart the application, and as it starts, it will check whether the database is in sync with the schema definition, and if it's not, it will run the migrations and make sure that it is, and then it will continue. So this is a very useful trick. I've added 2 helper functions because now we're going to have 2 different types of persons. I have the person that I use internally in F# that I can serialize to JSON and send over the wire and so on. And then I have this person that I get from this entity framework. And I think it's somehow possible to consolidate these 2, but what we usually do is that we keep them separate. And then I have 2 helper functions here. One is to person and one is from person. And to person takes an entity person and produces an F# person, and the from person takes a F# person and produces an entity person, and that's the one that is slightly more interesting to look at. So this from person, the first thing it does is it creates a entity framework person object by calling this default constructor that I had in model CS, this one here. Creates an empty person, and then we'll mutate that. So we will set the first name, the last name, and so on. And if there is an alias, we will set that too, and then I'll just return this person object. So the first method that we need to do is create. So how do we create a person? Create person takes a F# person, converts it from F# to a entity person, and then I create this query which will receive this context as an argument, and I say context add entry, and we just ignore it. It will return some stuff that you can check, but it will usually just ignore it. And then I say, well, save changes, and now I've received in my entry object has been mutated, and I've gotten this database primary key ID. So I will return that to whoever called this thing, and then I say run db with this query, and it will execute it. It will open up the database context, it will run this query, and it will close down the context for us so that everything gets cleaned up. Get person is slightly more interesting. How to fetch a particular person from the database. In this case, I want to fetch a person who has a particular first name and a last name. So then I create a new query. I say for I in context people find, and I'm going to be slightly sort of approximate here. So I will say find where the entry has a first name which contains the first name, and contains the last name. So we can do sort of partial searches with this. Again, run the query, and this time it will return a result. And I will map that to a form where I get the tuple with the person ID, which is and the person object, and convert it to a F# person. So this is, we're gonna need that in the client to have check on these things. The update function, again, same story. This will take a person ID to say which person we're going to be updating, and the person object. This is an F# person, and we're going to find the person with the right person ID, and then we're just going to update that object. Call context update, save changes, and finally we run the whole thing to execute it. Delete person, same story, person ID, get the right person out of the database, and then call remove and save. And then we have this final thing to get every single person out of the database, which just says for I in context people select I. So it will just pick out all of them. And then I will map the sequence to a list, and each person in the list to a F# person from an entity person. So this is sort of the database. This is just the database interface that we're going to be using in the server. Now we can look at the server. And this is more or less exactly the same server that we had in the previous lecture. I've just removed this static JSON file that we had that we were reading, because now we're going to be using the database. And I've updated this one route. Well, I think this is the same, except that this handle get people is going to be using our database now. Now I have two API endpoints here, init and people. Those are the same that we had in the previous example. Now we're going to have to add for this to get a proper full-scale REST API for this thing, we're going to add a little bit more stuff. And as you can see, all of these are get things, and now I've added a new one, which is a REST API for operating on a particular person in the database. So one is to get the person, and here I say, okay, get, and then I use a different, slightly different root function, one which is called rootf. It's like printf, and it says API person, and then there are two placeholders. So this will get called, for example, with API person / Jonas / Juselius. So it's a first name and the last name, and handle get person. Here we'll look at it. It will take these two strings in a tuple as its first argument, which will be the first name and the last name. So this way I can pick out stuff from the path in the request. Then I'm going to say root, anything else going to API person is going to be, I'm going to add a choose on this, and then depending on whether it's a post, put, or delete, I will deal with them. So all of these go to API person. And those which are just API person, I will then choose whether it's post, to add, put, to update, and delete, of course, to remove the person from the database. So the only thing we need to look at to complete this thing is how these things are these API handlers here, handle get person, handle add person, and update person, delete person, how they are implemented. And I moved them over to a separate module because otherwise we get so long files, and I like to keep things sort of short so that it's easy to scroll up and down. So here's the API now. So I changed the init function as well. So now it will, instead of returning just 42, it will return the number of people in the database. And we can see it creates a task like before, and then but now I say match db get people, which was the one down here, which will return a result of a list of persons or an error string. And then I will check whether everything went okay, and then I will get the list of persons, and I'll just set the value to the length of the list and then return that. Get people, so all of these are going to be almost the same, all of them. So handle get people, that will do the exact same thing, except it will, instead of returning the number of people, it will return the actual list of people. Handle get person, remember this is one which takes first name and last name, so it takes the first argument is a tuple with the first name and last name, and then there's normal just the next and context. And it will call get person with first name last name. If everything goes well, send off the person. Now this person object here is actually going to be a tuple with a person ID and the person, because we're going to need them in the client. Add person, well, here we go. This is going to be a post, so then we get this bind JSON async to fetch a person object from the request, and we call create person with that data, and everything goes well, we will return the person ID. Update person, same story, almost identical, and the same goes for delete. It's just the same story over and over again. So that's pretty much it. Now, if you go and look at the client, you will see that I've split things up into smaller pieces here again. So now I've separated out the view, and I've added a few elements. I've added some messages that flies so that we can deal with editing and so on. I'm not going to go through the details. You can look at the examples. It should be pretty easy to understand what's going on there. But we can go back to this one and we can have a quick look at how this works now. So I'm just going to reload, and we see that if you saw that it said strike counter 0, the request completed, it said 5. And I can still just change this thing up and down, right? Now we still have this hello people box, and where we can add new people to our database. But the first thing we're going to do is load. And then we get the list of people and the graphs, and you see that I've now added an edit and remove button to the end using font awesome icons. So you find the examples of how to use font awesome icons as well in the example. So we can add a new one here. We can say Jonas. I'll just say, oh, I ended up being 0 years old. So now we have that. But now what I can do here is actually I've made it sort of that I can edit. If I press edit on this, you see it removed my name from here and put it up back into the box. And now I can say, okay, 186, 186, age 45, update, and clears the thing and adds me back to the list. And I can still sort things. So here's a sort of, these are sort of typical things that you will need when dealing with user interfaces. So this will serve as a good example for you when trying to create a proper application. And I guess that's pretty much it. Oh yeah, we should probably be able to remove stuff as well. No, one of the things that I say, okay, fine. So now I'll just do a Control R, and we're going to reload the whole application and see that we still have the data, that it's actually been stored. So now it says that there are 6 entries in the database. I can load it, and we'll see that yes, indeed, here it is. And now we can just press the remove, and it's gone. And if I reload, it's gone. I might say before we conclude this example that I've sort of done the basics of this interface, but there are still a lot of things that can go wrong with it, and so it's not perfect. So don't take this as an example of if you do this, it's good enough, because I can show you things like if I press edit and edit and edit and edit and edit, you see what happens. Things go terribly wrong. So there's still a fair bit of sort of sanity checking and making sure and disabling functionality and so on. Creating user interfaces in general it looks very easy, but it's a lot of work because there are so many details that you have to take care of, and special cases and so on, and what people can find out doing. So here we can say, okay, so we can update this to 54, and I press update, and you see now I just have 1 entry here. But if I reload, I actually have 5. So they're all in the database. They haven't been removed. It's just my user interface is pretty crappy, and so there's work to do. So if anybody feels free to do it, please do fix it. Also note that this is a fairly general application, so we could suddenly change this whole thing here. We could just change the fields and change the names of things, and we would have a full-fledged to-do app with a due date and a create date, and we could set up dependencies on other people. It's all the same. So we could turn this into some useful application instead of this silly people list, by just changing a few names and tweaking the user interface a tiny little bit. So this is the point is just that this is really an application, a pretty crappy application, but it's application nonetheless. Right, so I think that sort of concludes this lecture, and the next one will be out hopefully soon, and I will do a little bit on functional testing. I will mention a little bit on unit testing, but mostly it will be on property-based testing, and we'll look at that. And then I might be, just because I'm interested in, I haven't used GitHub Actions yet because we are running GitLab. I might actually do a final tweak to this silly app and add GitHub Actions so that we get a proper DevOps pipeline on it, so that it will get built and tested and deployed and everything whenever I push it to GitHub, which would be nice to make sure that everything stays consistent. So that was it. Until next time.